Okay, welcome everyone. And one last video about matrices before we transition over to working with arrays and lists to talk about the efficiency of multiplication. We've talked about how we can use the cross prod and T cross prod as one way to improve efficiency in calculating, say, products of matrices. Another thing to consider is the order in which we multiply matrices can have a big effect on the number of computations that need to be performed and thus the amount of time it takes to compute those products. So if we consider a product, if say we have matrices A, B, and C that have dimensions that make sense so that the product AB times C and A times BC, all of these products are defined. And matrix multiplication, although it's not commutative, when I take A times B, I don't get the same result in general as the product of B times A. But matrix multiplication is associative. So if I'm taking the product of A, B, and C, it doesn't matter if I first do AB times C or if I first do B times C and then multiply that by A on the left. So regardless of the order in which I do these multiple, calculate the product or how I group the product, I'm going to get the same result in the end. So the question is, does it matter if I'm calculating the product of A times B times C, whether I first do AB and then multiply it by C on the right, or whether I do BC first and then multiply that by A on the left? And it can have a big difference overall in the amount of time. So let's consider the following example. Let's let A be a 50 by 2 matrix. Let's let B be a 2 by 50 matrix, and C is a 50 by 1 matrix. So you could check that A times B, that product makes sense because I've got two columns in matrix A and two rows in matrix B. So if I took the product of A and B, I'm going to get a 500 by 50 matrix. So that's what I've indicated over here. The product AB is going to be a 500 by 50 matrix. And then it makes sense for me to multiply that by matrix C, which is a 50 by 1 matrix. So when I multiply A times B and then multiply by C, that means I would need to calculate the product of a 500 by 50 matrix and a 50 by 1 matrix, and the result would be 500 by 1 matrix. So it's going to be a column vector. If I calculate this product in a different order, so say I first multiply matrix B and C, that is going to result in a 2 by 1 matrix. So if I multiply these together, the number of columns of B is 50. That equals the number of rows in matrix C. So that product makes sense. And what's left is a 2 by 1 matrix, much, much smaller than the 500 by 50 matrix that we get when we multiplied A and B. So now I've got a 2 by 1 matrix, which is the product of B and C, that I'm multiplying by a 500 by 2 matrix. So multiplying a 500 by 2 matrix and a 2 by 1 matrix involves much less calculations than if I did it the first way, which would require me to do a 500 by 50 matrix times a 50 by 1 matrix. So this is way more calculations. So it's going to take a little bit more time to calculate the product if I did it in that order, as opposed to first doing B times C, which is a really small matrix, and then multiplying that on the left by A. So let's clear this out and confirm this using the microbench package again. So you want to make sure that you still have that microbench package installed and loaded. But now I'm going to compare the product, how long it takes to do A times B first, and then multiply by C. I'm going to compare that to how long it takes to calculate first B times C, and then multiply that on the left by A. That's what this is plotting. I didn't run this code cell. So here, I'm going to just create some random matrices A, B, and C that have the right dimension. So A is a 500 by 2 matrix. B is a 50 by 2, is a 2 by 50 matrix. And C is a 50 by 1 matrix. Um, and when I calculate that product, you can see that on the left was how long did it take to do A times B times C? And that was the much larger calculation. So doing it in that order takes much, much longer than it does when we first calculated B times C and got just a really small 2 by 1 matrix and then multiplied by A. Okay, so that is a wrap on matrices. That was a lot of work on matrices. Next, we'll go through arrays and lists, and we'll cover those a little bit quicker because there's not as much arithmetic involved with arrays and lists.